Please welcome the main man responsible, Professor Brian Cox. You know what's so weird is no one would be talking about D-Ream at all anymore unless you'd been the keyboardist.
I might have known, you know. Yeah. I thought, what are they going to play? And I thought it's going to be...
Of course
things
it's going to
get better.
Of course it has to be that. But it is, you know what, I suppose people find that surprising because they don't think people who hold positions like you do currently, and they don't think people who have the kind of, you know, the mental faculties you do to have ever had a previous life. Normally it's, you know, it's a very, you know, focused, boffinish, nerdy life, and then not someone who's been on stage dancing around on top of the pops.
Yeah, and, you know, I mean, because I took about 5 years off before I went to university, so I was 18, got my A-levels. I can be sensible now and say kids, because it's really true, if you get your A-levels, you can pretty much do what you want for a while. So I joined a rock band for 5 years. And
is there a kind of presumption that scientists should look a certain way, professors should look a certain way, and the fact that you don't, people find that curious at best, off-putting at worst?
You get, you know, on Twitter or on the web when you get feedback from the shows, and people do tend to put young man after their comments, some people. So say, I'll tell you, I didn't agree with the colour of Saturn on that graphic, young man. You know, it's like I'm 42. You know, but I do get a bit of that.
Well, you're very youthful looking 42,
yes.
And that's because, we'll find out more about this later on, you've travelled through time, I believe.
Yeah, we all do.
Yes, we do travel through time, and is it possible one day, and I know you've dealt with this in the theoretical realm, that we will actually physically be able to travel through time in a direction of our choosing?
Do you know, you can travel into the future at any speed you want relative to other people. So it just depends on how fast you're travelling.
Well, say, but would I be able to see, but if the future hasn't happened yet, or has it happened?
It's a really good question, because...
Hold on, that's a first. Let's enjoy that. It's taken us 11 years, but we've got there. I'm off, my work's done. So that's a good question.
In Einstein's theory of space and time, the best theory that we have, then the space and time are like a blob. So really, there's no sense in which the future unfolds. It's there, and we're travelling into it at the moment. Now, that might not be right, but it's the best theory we have of space and time at the moment. What
is the universe made of, to the extent of our knowledge? Because there's a very large proportion of it that we can't identify. Is this correct?
We now think that something like 96% of it is made of something else other than this. And every star... And remember, there are 100 billion galaxies we can see in the universe, each with, in the observable universe, each with 100 billion stars in it, like our sun.
Headache.
That appears to be about, what, 4% of the stuff in the universe, which we've discovered in the last 10 years.
But the rest is
it's a bit embarrassing for fundamental physics.
So you don't...
96%
you don't know
of the
what
universe is something else.
Is this because it's not matter in the way we understand it?
It's not this stuff. It's not stuff that shines in stars or galaxies. It's something else. So we call it dark matter, and there's some other stuff around called dark energy, and that's what we know about it. Basically, it's got a name, and that's about it.
And if you go down to the quantum level, of course, this is the same as this is the same as that, isn't it? Is that right?
That's right.
Oh, that's hard.
This is very good.
But it's really hard to understand.
It is, but I think that it's... most people I meet are interested, genuinely interested. And I think, actually, that image of science being difficult is a problem that we need to get over, particularly for kids. It's not that difficult. I mean, I'm no cleverer than you. I can't believe I said that. I'm not. I'm no cleverer than you.
You can't laugh while you're saying it. There's so many questions that I'm sure people put you on a regular basis, but these are the kind of layman's questions about the universe and about space and time. I'm sure I would have thought the question about what happened before the Big Bang must be in the top 10 right there. The other one must be, is there life on other planets? Will we encounter it, say, in our brief time on Earth?
Yeah, and I would say, I mean, the last episode of Wonders is about this, life in the solar system. And over the last, let's say, decade or so, we found water everywhere, liquid water.
And we never thought there was before. We never thought there was water. I think they suspected there might have been on the moon, but they thought there was none on Mars, did they?
Frozen. But we found, for example, there's a moon of Jupiter called Europa, which is about as big as our moon. And it's got a frozen ice surface, because it's very cold out there, 500 million miles away from the sun. But it's got a liquid ocean underneath it, which is probably about 100 kilometres deep.
So fish and stuff we might find?
It means there's more water on that moon than in all the oceans of the Earth put together.
Once again, big headache time
and
for me. But will there be fish in there and
well, there could be microbes.
crocodiles?
Many people think there'll be at least microbes around. And the big question is, are they different or the same from the ones on Earth? Has life evolved?
All right, that's fine. But listen, never mind that.
You
what we want to know, though...
Life!
Microbes don't count. We want things with arms, eyes...
I know.
Guns, you know, hats. That's what we're interested in.
Microbes would be a start.
No,
they would.
Microbes!
But it would mean that our planet is not the only place in the universe where life has evolved, which would be a massive discovery and potentially within our lifetime.
But isn't that a given?
Well, no, because we've only found one, and you can't make assumptions about nature.
Well, we haven't found one. We are one, is what you mean.
Well, yeah, so there's this planet which has life on it.
Okay.
And until you see it somewhere else, any form of life, then you just don't know.
Yeah, but you know it's there, really. I mean, I know it's there.
We could save a lot of money.
But
we don't need to bother.
I don't need you to find a microbe. I'm telling you now. There's some microbes out there on one of those planets. Probably that big one with the water you were talking about earlier.
Do you know they can move around in space, though? We sent some space probes to the moon before the Apollo astronauts went there, and they brought a camera back of one of them, and someone had sneezed in it when they were assembling it. So it had flown to the moon, sat on the moon, been brought back by the Apollo astronauts, and the cold virus, the viruses, the bacteria was still there, and they were still alive. So they came back to life.
So
they survived.
That's
on
terrifying,
the moon.
though. That is like a science fiction movie.
It's like the Andromeda strain.
Yeah, so the microbes could travel through space. So is there a cold virus coming from that big moon planet now?
There's a theory that life on Earth was seeded by microbes from comets and things hitting the Earth back in its past. So it didn't start here. There's a theory that it could have started somewhere else.
The Big Bang
on Mars
could have been
else.
someone sneezing.
No.
You can't say
You can't extrapolate
There's
from
no
what I just said to that.
I can, and I will.
You will.
And if you sit around for much longer, you're going to have more of this sort of bullshit. So you might as well just relax, loosen the belt, kick off those shoes, get ready to join in. God sneezed. Are you agnostic? Are you an atheist? Do you have any... do you want to have a faith in the unknown, or is science your God?
Yes, it is in the sense that I'm comfortable with the unknown. That's the point of science. There are places out there, obviously billions of places that we know nothing about, and the fact that we know nothing about them excites me, and I want to go and find out about them. And that's what science is. So I think if you're not comfortable with the unknown, it's very difficult to be a scientist. So I don't need an answer. I don't need answers to everything. I want to have answers to find.
Well, that brings us to the giant Hadron Collider.
The large Hadron
or as I believe
Collider.
it's known in science terms, the death machine.
Don't eat that bollocks, and I knew you'd start talking bollocks.
That's what I heard for some scientists I met in a bar.
Do you know in the Telegraph the other day, they actually had a title in it, and it finally said the spelling mistake everyone's been waiting for, Large Hadron Collider. and you know what? Stephen Fry, of all people, sent me an email going, yes! It was so juvenile. And it was the Telegraph. The Telegraph of all
Most
things.
people have a rough idea. We have a rough idea of what it is, where it is, what it's doing. But if you can clarify for us, this is a huge, I believe it's a huge underground tunnel in a big section. It's near Geneva, is that right? It's
Yeah, so that's 21 kilometres in circumference.
Wow.
And it's below the surface of Geneva.
How far below the surface of Geneva is it?
About 100 metres.
So it's a long way down. This is the inside of one of the tunnels, I believe, which I think I saw something similar in Doctor Who with some Cybermen running down a while ago. So they all look pretty samey, don't they? And in there, and can you still go down there, or is it now radioactive?
It's working now. So there's radiation in there now.
And so this is are these protons or neutrons going around?
Protons, the nuclei of hydrogen, and we accelerate them around there to 99.999999% the speed of light.
So can you go to the speed of light?
No, just below. If you've got no mass, you can go at the speed of light. But
so because they have a tiny amount of mass, they can't actually get to the speed of light.
99.99999, that's 11,000 times a second they go around that ring.
Wow.
And we can collide them together, and we collide about full power, 600 million every second.
When you say come together, this is where there's more than one going round in each direction.
Yeah, millions, billions.
So you're banging loads together.
Yeah, there are beams of them, which are actually, when they collide, they're about the diameter of a human hair, and they have the energy of an aircraft carrier going at 30 miles an hour. Wow. And you cross them, and in those collisions, you recreate the conditions that were present less than a billionth of a second after the universe began.
Just after the sneeze. Now, when they...
No, but anyway.
You can't say no, you say probably not. Now, to help explain to the layperson, unlike us, I have created a small working model of the Hadron Collider. and you can perhaps join with me. Who knows, we may make a discovery here. Will you please bring on Mini Hadron? Here it is. Now, I've made this using household appliances of the sort that you can find at anyone's home. And we get sent a lot of stuff into the show. Some of them are adult products. I've incorporated as many of those as I could find in this on as well.
I know what they are, but I mean, what actually is it?
I don't know. It's a radio, I believe.
Is it a radio?
In the shape of lovely boobies. This is turns it on. This is a personal massage unit that was sent in. And we see now, and like, if you want to do the photons on that side, I'll do on this side.
Where do they go in?
And they're going to hit down there. Well, this was off a rabbit. Okay, here we go.
I've broke. Oh no, there we go.
Look, is this in any way scientifically useful to you, Brian Cox?
I actually think we've wasted our money. We could have just done it with this. It's a bit big as well. It goes through Madrid and Rome and...
Yeah, it's a bigger Hadron Collider. This is my scale dream. And this, I don't want to spoil you.
What is that?
What, that? I wouldn't touch it. It's a butt plug. I really wouldn't. Yes, it's not.
Actually, is it dangerous? I've taken the end off it. Is it dangerous, isn't it? It's got electrodes.
I don't want to answer that question in front of Emma Thompson.
It's got electrodes in it.
Yeah,
it's
you know where we got that?
It's a battery.
Of course it's a battery one. It's a vibrating butt plug we got from the Blue Peter cupboard. I think it was Shep's. Would you like to take home the Mini Hadron?
I'll take home bits of it.
There was speculation, there was some panic mongering that went on when the Hadron Collider was announced that you were going to start operation, that it would be the end of life, possibly, potentially. There was a chance that things might happen that, because it was unknowable, then maybe it would be the worst case scenario.
I mean, it is bollocks, complete bollocks.
Is that but the thing is, that kind of argument is kind of thing?
Yeah, it is. I mean, it's a really weird argument, isn't it? It's like, we don't know, and it's not we, it's whoever it was who made this stuff up says, I don't know, therefore, the world's going to end. It doesn't follow.
It's an exciting story. To say we might find out something isn't a headline. To say, the world's going to end. And I'll be honest with you, if it had just been Switzerland, I wouldn't have been as upset. I don't mean that. When will you know if you've discovered something truly momentous? When will you know if this experiment has borne the kind of fruit that you obviously hope it will? It
will at some point. We know it will tell us one fundamental thing particularly, which is the origin of mass in the universe. So literally why that's solid and why we are solid. That question, what is that? We don't have an answer to that at the moment, and that machine will tell us that. You might have heard a thing called the Higgs particle. That's a theory.
Is it the Higgs boson?
Higgs boson, that's right.
Desk.
Yeah, but why is it?
Wood.
We wasted our money with that thing, haven't we? We could have just asked you. And
I'll come around with you for a year. Yeah. You point at anything, and I'll tell you what it is. All right, let's have a look. We're going to do a little experiment here for you, ladies and gentlemen, involving liquid nitrogen, which is one of the coldest substances you can have in this kind of environment. Isn't it?
This stuff is about the same temperature as Titan, the moon of Saturn, which was on the show last week, actually.
Yeah,
it's
I
amazing,
saw that. Is that the coldest moon?
Place. No, there are colder places.
But that's the coldest moon around Saturn, isn't it?
Yeah.
Where's the coldest place? That's way out, isn't it? A long way from the sun.
Yeah, you'd have to go out.
What happened to poor old Pluto?
It got demoted in the sense that...
I know, it's not a planet anymore.
Well, because there are other objects like that around. So there are either hundreds of planets in the solar system or 8. It's a little ball of rock.
Is it?
Tiny ball of rock.
Same thing, really, as a gas giant.
So, yeah. So this is...
Right, so we've got there... Don't try this at home if you can find it. So if I was to put my finger...
Don't try this at home. It's liquid nitrogen.
If I put my finger in there, this would freeze my finger, wouldn't it?
Yeah.
Ooh, but I'm sort of...
It's minus 190
But I'm sort of tempted to put a finger in, because I don't believe it.
Put the rose in.
So if this was my finger, this is what would happen, yeah?
Yeah.
Where did you get this sort of stuff from? Science shops.
Science shops, yeah.
Right,
so that's the temperature on the surface of the moons of Saturn. So that...
Oh, look at that, it's very pretty.
...is what would happen to you.
OK, so is this frozen now?
Yeah.
Let's have a go. I've got a little hammer. Man, look at that.
That's why I said don't put your finger in.
Yeah. But you see, here's the difference between us. Part of me still thinks my finger would be OK.
What about this? So this is a...
I do. OK. That's
This
an
is
egg.
an egg.
You can't fool me.
So let's pop that in there for a while.
Would this be cooked like a boiled egg?
Well, it's freezing it. But I mean, I think the amazing thing is this is what it would be like if you went to the moons of Saturn.
I'll get it out.
Don't do that. I don't just... I'm kind of...
Brian, if I did it quickly,
I think
it's the 10-second rule. It's like germs.
I know I'm not responsible for you, but I think you're mad enough to do it. I'm
seriously?
genuinely worried.
How can it be that cold?
Did you see what happened?
I'm just going to pop in a little bit.
Look.
How can it be that cold?
What about a banana?
What about a banana? Let's put the tomato in there
We're
as well.
breaking every possible regulation in the BBC.
So this is quite dangerous. What are these? Are these for drinking if you get too warm? Why are these in styrofoam cups? Well, that was cold. There might be something in this science lab after all. Look at that.
Tomato.
Hold on, no. Let's enjoy that. It's a totally frozen cherry tomato. Where else can you see this kind of thing? Well, Jesus!
I don't want
In what way was that necessary or scientific?
I don't want to pick it up now. I've got to get the...
Why don't you want to pick up your big baby?
It sticks to my hand and I never got to get it off.
I don't know what's happening to this banana.
Look at
That is a rock-hard tomato. Eh? God, what are we proving with this, exactly?
The demonstration is that it's remarkable. There are worlds. Titan, the moon of Saturn, is that cold, but it's got lakes and rivers and rain on its surface.
Wow.
But it's lakes of methane.
Do you think,
Let's get this egg
Brian,
out.
do you think there might be life forms watching us even as we speak?
Well, those... we're not on our own.
A few more than that. All right. No, but, Brian, remember, have you seen, like, on Star Trek and these sort of things, where they go to a planet and they're... Because we're silicon, aren't we? No, we're carbon. Oh, right,
Jordan.
We're
again.
carbon. We're carbon.
Think about something else.
Could there be a silicon life form?
It's a good question.
Yes.
Computers could possibly be conscious. People think about this, and computers would be a silicon life form. So that might be our future. Are you just touching that?
The coldness of the banana has reminded me I should have been wearing goggles and gloves.
If you eat that banana, your eyes are going to be the least of your worries, I can tell you.
This is the most fun I've ever had with liquid nitrogen.
Here we go, this egg's done now.
This egg's done now. That is...
that
Hold
really-
on, don't splash it. We now know. It's the most lethal liquid on Earth.
Here we go. So
My love is
that's
for
what
you.
an egg would be like on Titan. But that is the temperature of these moons. It's quite astonishing.
Brian, it's...
Yes.
I must admit, when we invited the top physicist in the country onto the show, I didn't expect we'd wind up with a desk like this. A frozen banana, some roses and a broken egg. However, it's been fabulous. I could talk to you all night. What a fabulous series. It's on BBC Two on Sunday nights, and you can watch most of my guests on iPlayer as well.
Yeah.
Brian, great to see you again. Thank you so much. Mr.
Thank you
Brian
very
Cox,
much.
ladies and gentlemen.
Thank you.